In this problem here, we have a system of equation, and so we're going to read the word problem and follow some rules that I have set in place, some procedures to help you be able to write the three equations, because we're going to have a system with three different equations, and then we're going to use substitution and elimination to solve it. Notice it says, if you spend $22 buying ingredients for a fruit punch, that's one item. I'm going to go ahead and label that with a variable F. It says each 32-ounce bottle, so I'm going to box it because I'm boxing all numbers and variables. It says of pineapple juice. Okay, so pineapple juice is P. Apple juice, it's going to draw a line out, and I'm going to call that A. And ginger ale, I'm going to call that G. And I'm just labeling the things that it's talking about. And then it says they cost $2.50, $2 and $1.50 respectively. And respectively just means in the same order in which they were mentioned. In other words, pineapple juice is $2.50, apple juice is $2, and ginger ale is $1.50. It says the recipe calls for the amount of ginger ale to equal, that's a key word, so I'm going to underline it, the combined amount of pineapple juice and apple juice. You buy a total of 12 bottles. How many of each type of bottle did you buy? So we're going to go ahead and we're going to create an equation from this with the information that I've boxed. And so what I want to do is, I noticed that when it talked about how much I spent, I'm going to put a note up here. That $22, that was the total I spent. So I'm going to put total spent, because we're going to use that to make our equation. And now looking at it, I realized they're trying to make fruit punch, but there's not going to be a single variable for fruit punch. So I'm going to ignore that variable that I had put up there. And I'm going to go ahead, I'm going to write my first equation. So what I know for certain is that I know the cost of each of the three items. And I know that the total cost of it was $22. So I'm going to write that equation first. So I'm going to go ahead and say, well, it talked about pineapple juice. That's my P variable. So, and it's $2.50 per bottle. So I'm going to say $2.50 times P, which is the number of pineapple juice that we bought, plus $2, which is the apple juice. So it's going to be $2, and there's going to be A after it because it's $2 times the number of apple juices we bought, plus, and we're going to have $1.50 for our last one, and that's going to be the ginger ales that we bought. So I'm going to put a G after it because it's $1.50 times each ginger ale bottle, and this is all going to be equal to our total of $22. So that's our first equation right there. Now I'm going to go ahead and create the next equation. Now the next thing that I saw in here is it told us that the recipe calls for the amount of ginger ale to equal the combined amount of pineapple juice and apple juice. So when it says combined pineapple and apple, we're going to add those two together. And they're all equal to the ginger ale. So I'm going to say on here that the ginger ale, so I'm going to put a G, is going to be equal to the apple juice plus the pineapple juice. So that's the second equation. Now they didn't give us any numbers, we just write the equation with the variables. Ginger ale is going to be equal to the amount of apple juice plus pineapple juice. And then I'm going to go ahead and I'm going to write the next one. So it tells me how many bottles we bought, and it said you buy a total of 12 bottles, right? So that's total bottles. So if I were to write that, I'm going to go ahead and write it as the pineapple juice, so P, plus the apple juice, plus the ginger ale is equal to a total of 12 bottles. So now I have three different equations, and we're going to go ahead and set these up. Now I hope you noticed that this one I wrote that ginger ale was equal to the apple juice and pineapple juice. This is going to be I'm going to use my highlighter. We already have it set equal to G because that's how it was written in the story. And we're going to actually substitute this in to go ahead and make it easier to solve. In other words, I'll be substituting this G in for the variable G here, and I'll be substituting in for the variable G here as well, and then we're going to solve for one of our variables. Alright, so now let's go ahead and start doing some of this work. So I'm going to rewrite this first one up here. So I'm going to go ahead and block this off. And I have 2.5. I'm going to leave the 0 off. That way we have a little bit less digits to deal with. And I'm going to put P plus 2A, because 2.00 is the same thing as 2, plus 1.5. But instead of a G, I'm going to put a set of parentheses because we are now going to substitute the value of G in here. You know what? I'm going to change that one to all black so you can see clearly. Now we got G is equal to A plus P. So what I want you to see is this G right here. Instead of writing a G, I'm just going to put what it's equal to, which is A plus P. And then that's going to be equal to 22. So we have now went ahead and filled this out. We just have this equation written with G substituted for A plus B. And now I'm going to go ahead and we're going to solve this. The first thing we want to do is we want to go ahead and we want to distribute the 1.5. So therefore I end up having 1.5 times A. So that's going to just give me 1.5A. And then we have 1.5 times P. And so that's going to give me a positive 1.5P. I'm going to bring down the 22. So this is equal to 22. And I'm going to bring down these other values. So we got 2.5A, or 2.5P, plus 2A. And this 1.5A, right, that was positive. So now what we're going to do is we're going to want to combine like terms. So when I'm looking at it, I notice that I have this positive 2A right here, and I have this positive 1.5A. So we're going to put those together. Now if I combine those two terms, 2 plus 1.5 gives me 3.5. So this would be 3.5A. So we got rid of those. And now I'm going to go ahead and I'm going to circle the other two we could put together. We have 1.5P over here, and we have 2.5P. So we're going to go ahead and combine those two terms. And I'm just going to use a different color just so you can see that I am combining these. And 1.5 plus 2.5 is going to give me 4. So I end up with 4P. So now this equation has changed to 4P plus 3.5A equals 22. So now we only have two variables, and we're ready to use this in a system of equations. In the sense of we're just going to use a system that uses two equations. Now I need my second equation, and so for my second equation I'm going to do this substitution again for G, but I'm going to do it with the third equation that we had made. So I'm just going to draw a line here just to keep it separate so you can see. And I'm going to write this out. So we have P plus A plus G. But instead of a G, I'm going to go ahead and substitute the value for G, which is A plus B. So A plus B. And this is all going to be equal to 12. So we do have some work we got to do here. Now we can drop the parenthesis because notice there is an invisible 1 in front of this parenthesis, right? But if I distribute a positive 1 to those, it doesn't change anything. But what we can do at this point is we can combine the like terms. So in other words, let me just rewrite this. This is really just going to be P plus A plus A plus P equals 12. Now what I'm going to do is I'm going to go ahead and just circle what I'm going to combine. I'm going to go ahead and combine my two A's. And notice I have two A's there, so that becomes simply 2A. And then I'm going to combine the P's. So we have one right here, so that's 2. So we have 2P. And this is all equal to 12. So there's my second equation. Now I'm going to take this equation and just write it over here so that we can do elimination. So I'm going to move my paper up just a little bit. And I'm just going to take this whole thing over and write it. So I end up with 2P plus 2A equals 12. Now, I need to manipulate one of these equations so that we can cancel one out. So what I hope you notice is that we have this 2. It'd be very easy to turn this 2 into a 4. Now, if I wanted to cancel out, not only does it have to change into a 4, but it has to be a negative 4 so that we can create a 0 set here. So I'm going to go ahead and use elimination. I'm going to write right here, elimination. What we did before was substitution to create these two equations. And I'm going to put parentheses around the entire equation. That just reminds me that I have to multiply the entire thing by a number that's going to make this 2 become negative 4. So to make a 2 become negative 4, I got to multiply it by negative 2. And then I'll go ahead and start distributing. So negative 2 times 2 gives me negative 4. So this becomes negative 4P. And then I also have to multiply it to the second term. Negative 2 times 2 is going to make that a negative 4A. And then I have to take that negative 2 and multiply it to the 12. And that's going to give me a negative 24. So I'm just going to draw a line through this now. I'm going to ignore this one from now on. And we're going to work from top to bottom and start eliminating what we can and combining like terms. All right, so I think because this is so close together, I'm actually just going to go ahead and rewrite it over here. The two equations, right? We just created these equations here. And so the top one, I have 4P plus 3.5A equals 22. And then after we distributed that negative 2 to all three terms in the second equation, we created this new one down at the bottom, which is negative 4P minus 4A. And that's going to be equal to negative 24. So I think it's real easy to see now which ones can be eliminated, which we said our goal was to eliminate the 4's, which we have. Those are gone. And now we're going to go ahead and we're going to combine these terms, this 3.5A and negative 4A. So I'm going to go to my calculator. I'm just going to put the coefficient in there. So 3.5 plus negative 4. And that tells me that it's negative 0.5. So now we have negative 0.5A left over, and that's equal to, and right here we have 22 and negative 24. So 22 plus negative 24. And that gives me negative 2. Almost forgot to put my A after that 0.5. There it goes. So now our final step, right? We just got to get rid of this coefficient of A, which is negative 0.5. So I'm going to go ahead and divide by negative 0.5 on both sides of the equation. Those cancel, and I'm simply left with A is equal to, and I'm going to grab my calculator and see how many times can negative 0.5 go into negative 2. So I got negative 2 divided by negative 0.5. And it tells me that it's 4 times. So A is equal to 4. So while we still got some work to do, at least we know what A is. So in other words, A was representing our apple juice, and so we know that we had bought 4 apple juice containers. So let's go ahead and continue this process. We're now going to take this A and substitute it back into another equation. All right, so what I'm going to do now is I'm going to just box off an area where we can substitute that value in. And I'm going to go ahead and use an equation that I feel like was pretty easy that we had in the beginning. So for instance, we had this 2p plus 2a equals 12. So I'm going to use that equation. So 2p plus 2a is equal to 12. And now since we know what a is, we can substitute the a value. So really what I end up with is 2p plus 2 times our a value of 4 is equal to 12. And if I continue to do the math, 2 times 4 is going to give me 8. So I got 2p plus 8 equals 12. Then I'm going to go ahead and use inverse operations, and I'm going to move this 8 to the other side of the equation. That cancels, and 12 minus 8 is going to leave me with 4. Move this up just a little bit. And we still got this 2p over here, right? I should draw a line through here, just keeping it separated. So I got 2p right here. So we know that this is 4, our constant is 4, and we don't want a coefficient of 2, right? We want a coefficient of 1. So I need to divide by that coefficient of 2 to isolate the variable p. And I end up with p is going to be equal to 2. Because 4 divided by 2 is 2. So now we found 2 of them. We found A is 4, and we found P is 2. So we got 2 containers of pineapple juice, and we have 4 containers of apple juice. So to find the third one, to find how much ginger ale we had, we're going to use the most basic equation that we made in the very beginning when we wrote this problem. The equation's down front of this word problem. I'm going to use this one right here, which is ginger ale is equal to A plus P. So I know what A is, and I know what P is. I just got to add those two values together. So let's go ahead and substitute those two values in real quick. And let's see, we have the ginger ale is going to be equal to the A value plus the P value. So let's substitute those in. For A, we had 4. So I'm going to put in parentheses 4 plus, and for P, we had 2. So put a 2 in there. And that's going to tell me how many we have for the ginger ale. And 4 plus 2 is simply 6. So we have successfully solved this equation, right? So it had 3 different equations in the system. We know that we have 4 containers of apple juice, 2 containers of pineapple juice, and we have 6 containers of ginger ale. And that's it. That's how you solve a problem like this.